Rajshahi, Higher Maths 2017, Question 1. We are given the function of x equals 2 over x minus 3. In part A, we've got to find the domain of the function of x. Now, to solve this, what we're looking for is any values that x cannot take. Well, x can be any real number except the number 3, because the function of 3 is 2 over 3 minus 3, which is 2 over 0, and that's not defined. You're not allowed to have a fraction with a 0 on the bottom. So the domain is R minus the set containing the number 3. In part B, we're asked to determine the inverse function of 5. Well, one way to do it is to actually work out what the inverse function is. What we have is y equals 2 over x minus 3, and we want to make x the subject of the equation. So y equals 2 over x minus 3, multiply both sides by x minus 3, y into x minus 3 equals 2, expand the brackets, so xy minus 3y equals 2, get all the terms with x on one side and the rest of the terms on the other. So that means we add 3y to both sides. xy equals 3y plus 2. If we divide by y, we get x equals 3y plus 2 over y. So, changing the y's back to x, we get the inverse function of x is 3x plus 2 over x. Now, the inverse function of 5 then is 3 times 5 plus 2 over 5. So, the inverse function of 5 is 17 over 5. For an alternative way of doing it, we want to find the inverse function of 5. So, let x equal the inverse function of 5. Then, the function of x equals 5. Now, the function of x is 2 over x minus 3, so that's equal to 5. Multiply both sides by x minus 3. 2 equals 5 into x minus 3, or 2 equals 5x minus 15. Add 15 to both sides, 17 equals 5x. Divide by 5, x equals 17 over 5. Now, for part C, we want to draw the graph of the given function. So, we're going to draw the graph with y, so let y equal function of x, which is equal to 2 over x minus 3. And we want to draw out a table. We're going to choose values of x. Now I've chosen them from minus 3 going up to 7. And we want to work out the values of y. So if we take x as minus 3, we have function of minus 3 equals 2 over minus 3, which is 2 over minus 6, which is minus a third, or minus 0.33. If we take x as minus 2, we get 2 over minus 2 minus 3, which is equal to 2 over minus 5, which is equal to minus 0.4. If we take x as minus 1, we get function of minus 1 is equal to 2 over minus 1 minus 3, which is 2 over minus 4, which is minus 0.5. If we take x as 0, then we get the function of 0 is 2 over 0 minus 3, which is 2 over minus 3, or minus 2/3, which is equal to minus 0.67. If we take x as 1, then the function of 1 is 2 over 1 minus 3, which is 2 over minus 2, which is minus 1. If we take the function of 2, that's equal to 2 over 2 minus 3, which is 2 over minus 1, or minus 2. If we take x as 3, the function of 3 is 2 over 3 minus 3, which is 2 over 0. That's not defined. That's not a correct number. If we take the function of 4, then we get 2 over 4 minus 3, which is 2 over 1, or 2. If we take x as 5, we get 2 over 5 minus 3, which is 2 over 2, which equals 1. If we take x as 6, then we get the function of 6 is 2 over 6 minus 3, or 2/3, which is equal to 0.67. If we take x as 7, then we get y is 2 over 7 minus 3, which is 2 over 4, which is equal to 0.5. Now a couple of other useful numbers to take would be x is equal to 2.5 or x is equal to 3.5. If x is equal to 2.5, the function of 2.5 equals 2 over 2.5 minus 3, which is 2 over minus 0.5, which is equal to minus 4. If x is equal to 3.5, then the function of x is 2 over 3.5 minus 3, which is 2 over 0.5, which is equal to 4. Now, having filled in the table, we can plot those points on a graph and join with a smooth curve. The points are minus 3, minus 0.33, minus 2, minus 0.4, minus 1, minus 0.5, 0, minus 6.7, 1, minus 1, 2, minus 2, 2.5, minus 4, 3.5, 4, 4, 2, 5, 1, 6, 0.67, 7, 0.5. That gives us the graph that we want.